Welcome to VK videos. Today we are going to discuss about voltage sags and interruption. Actually this topic come under the subject of power quality. In power quality there are various issues affected. They are voltage sags and interruptions, voltage swells, under voltage, over voltage, harmonics, frequency variations and so on. Now in this videos we are detailed about the voltage sags and interruptions. First we are going to discuss about the definitions. The voltage sag is a short duration, typically 0.5 to 30 cycles, reduction in RMS voltage caused by faults on the power system and the starting of large load such as motors. The momentary interruption causes a complete loss of voltage and or a common result of the action taken by utilities to clear transient faults on the system. It is typically no more than 2 to 5 seconds. The sustained interruptions is of longer than 1 minute are generally due to permanent fault. So it will be a 0.1 per unit will to 0 per unit. Okay. Then there are a number of reasons for this, with the most important being that customers in all sectors, it may be a residential or commercial and industrial, have more sensitive loads. The use of digital computers and other type of electronic controls is at the heart of the problems. So next we are going to discuss about the sources of sags. Actually how the sags will be propagated in our electrical lines or electrical systems. There are majorly two things. One is the fault occur on the system. Occur on the system means it may be occur on the power lines or the equipment and load sectors. And when we switch on the larger loads such as induction motors and so on, these are all the very major causes for voltage sags. Okay, let us discuss about a one line diagram. Here in one line diagram, this is the transmission system and this is the distribution system. Here these are all the distribution feeders, feeder 1, feeder 2, feeder 3 and 4 and so on. All the feeders can get the supply, that is supplying from the transmission system only. If any one of the feeder, for example feeder 1 can experience a fault, which may be the occurrence of fault in the first feeder line. Therefore the customer or the distribution system can experience the voltage sag, and also the parallel lines may be another feeder can appear the faults. Meanwhile the voltage sag will be propagated. Okay, not only in distribution side, in transmission side also can be a fault occur between A and B, that is A circuit breaker and this is B circuit breaker. This is the SLG fault. It may be the fault occur on the line in transmission line between A and B. Immediately the A circuit breaker and the B circuit breaker will be open to clear the fault. So during the fault occurrence, the distribution side or the customer side can experience the voltage sag. Okay, so wherever the fault occurrence, it may be a transmission side or distribution side, what will happen? Immediately the breaker will be open to clear the fault. The recloser operations will take care about 5 or 6 cycles, and it remain typically open a minimum 12 cycles to 5 seconds. Okay, so if it is occurrence of fault in transmission system, that is there are two lines of the transmission system can supply to distribution system. So the fault occurrence in one line means what happened, there will be a voltage sag occurs in distribution side customers. Okay, and here this diagram shows the fault location that caused misoperation of sensitive protection equipment at an industrial facility. So actually this diagram was taken in this industrial side. So here there are three causes are there. The causes occurrence of the faults in transmission system, or the causes the fault occur on the parallel circuit, and this is faults on own circuit. Own circuit means the industrial side, that is this is one of the industrial statistical report. So here the customer, that is very own equipment, can experience very 23% of accountability faults in the particular industrial customer. Okay, so therefore when the parallel lines fault can experience about accountability 46%, and the transmission system faults occurrence accountability is 31%. Okay, so what we have to understand is the equipment misoperation also that leads to voltage sag and interruptions. Okay, this is the picture. Actually this is a faulted system. They are taking phase B voltage, and this is the RMS voltage in the upper chart, and this is the system voltage, percentage voltage. These are all the here there will be a 65% of the voltage sag occurrence, the seconds 0.16 to 0.2 seconds. The durations of the sag occurrence 0.050 seconds actually, and these are all the milliseconds taken from 0 to 175. First 175 milliseconds voltage variation chart they are shown here. Okay, this is another thing. So here there are two ways representation. First one is the fault locations can accountability in the particular system have taken two, that is this is the first location, and this is another locations in the particular utility. Okay, so this is unnoticeable. About the seconds is 2.5 to 2.257 seconds. Okay, and here this is obviously that know that 0 to 175 milliseconds. So in this recloser operations, the voltage blinker and someone these things are happening. So this is very rare. So what we have understand is, if the fault occurrence on the utility systems, it happens immediately the breaker will be take care of the problem, even though it will not completely restored in the first operations. So it will be take the recloser operation in the second stage also. Okay, so this is understanding. From the study we have to understand a few things about the typical event. The voltage did not go to zero. The line recloser detected the fault and operated very quickly. Since the voltage did not collapse to zero during the fault, The induction machines will continue to have excitation and continue to feed the faucets. Okay, thank you for viewing this video.